This week's design quiz had 2 problems for you to complete. The first asks you to design a function that consumes 2 rosters of players and produces true if all players on both teams will get to play. The second problem assumes that 2 teams have the same number of players and asks you to design a function to produce the list of matches that will be played between them. So let's get started on the evaluation. The first criteria we're going to look at is commit ready. So we want to check that the file is neat and tidy, no code is commented out other than stubs and templates, and that there's no scratch work left behind. So we'll take a quick look through the file. This is our solution to our first problem. And for the second problem, so that looks great, and we can give this a good for commit ready. So the next criteria we're going to look at is design completeness. So we'll scroll back up to our first function. So let's see, we have a signature purpose, check expect stub, our completed cross product table, and the function body. Those all look well formed and they're all present. And then in our second one, we have all of those elements once again. So we can give this a good for design completeness. So the next criteria we want to look at is internal quality. And we want to focus specifically on the 2 one-of elements of the design because that's the material from this week. So we want to check that we have our cross-product table, that it's properly simplified, that we have at least as many check expects as there are cells in the table, and that the function body matches the structure of our cross-product table. So let's start. We have 4 check expects up here. So let's see, we have one for empty empty, which matches with this case in our table. We have one where the first list is empty and the second is not. So that's this case down here. We have the opposite of that, where the first list is non-empty and the second is empty, which is here. And then we have 1 check expect for this final bottom cell. That seems pretty good, except for I think we're really missing a case, because we have the case where this final cell produces true, but we're not testing one where there are different numbers of players and it will produce false. So really we should add a test. I'll just copy this here. If we add a player, how about Erica, to this list, then this should produce false. So let's run this and make sure it works. And it still does. So we were missing 1 test there, but other than that, it looks pretty good. Now let's take a look at our cross-product table and see how it's been simplified. They've labeled their cells, so they have 1 case here where it's true if both lists are empty. If 1 list is empty and 1 isn't, then it's going to produce false because there will be players on 1 team that will not get to play. So that looks good. That's case number 2. And then in this third one, we have to run the natural recursion on the rest of both lists. So that looks good. Let's see how the function body relates to that. We check if both lists are empty and produce true. That's good. In this second case here, we know that both lists can't be empty. So we're saying if either one is empty, then we're in one of these 2 cases. So that's going to produce false. And then here we have the natural recursion. So this looks great. All tests passed, so the function works well. We just had that 1 problem with the check expects. So let's move on and look at the second problem. Our signature looks good, and our purpose looks good, although in the problem statement, it told us we can assume that both players have the same number of teams. So we should really write that in here. So we can say assume both teams have the same number of players. Okay, so that's a small issue. We'll move on to look at our check expects and our cross product table. So if we look at our cross product table, we have included this assume in here. We've said it's impossible to have the case where team 1 has more players or team 2 has more players, which leaves us with 2 possible cases where both teams are empty and where we have to run the natural recursion. So let's look at our check expects and see what's going to happen in those cases. This here matches up with this first cell in the table. If both teams are empty, then there's no matches to play, so the list of matches will be empty. This test has the first roster empty and the second not. So something's gone wrong here, because if we look in our table, that would be this cell here, which we've said is impossible. So this test really shouldn't be here. If it passed, then we've probably fluked into having it work in our code. So we'll take a look at that when we get there to see what went wrong, but we really shouldn't have that test. We'll comment it out for now. This third check expect looks at the case where both teams have 2 players, and it makes a match out of the first one and cons it on to the matches of the rest. So that looks great. and that's this case here. We have a test for both of these cases. We had that extra one, which we'll look into, but other than that, it looks great. So let's look at our function body. So we're checking if R1 is empty. This works because we know this is the only possible case in which one of the lists is empty. So we don't need to check that both are empty. We can just check that either R1 or R2 is empty, and if so, we're going to produce empty. So it seems that because we've decided to check for R1, that's how we ended up having this test pass, because R1 is empty in this case, and it doesn't even look at R2. So that's how that happened, but we really don't want that test around, so I'll delete it now. And then if we keep looking here, in the else case, we make a match out of the first two, and we cons that onto the recursion on the rest of the list. So that looks great. If we run it, our tests pass. So we had two problems with the check expects. In the first problem, we were missing a check expect, and in this one, we had one we shouldn't have had. And we were missing that assume in the purpose. So that's kind of 2.5 mistakes. We'll give it a fair for our internal quality. Okay, so the final criteria is satisfied the problem statements. So we want to make sure that we did everything that the problems asked us to, and that we resolved any ambiguities. So these problems looked really good. In both problem 1 and problem 2, we designed the function that was asked of us. We had clear purposes, which made sure there were no ambiguities in what we were asking for. And in both cases, our functions were complete and correct. So this is a really great solution. You can now apply this rubric to your own solution. Be sure when you're doing your assessment, you pay really close attention to the correspondence between the check expects, the cross-product table, and your function body, because that's what we're really focusing on in this design quiz. And if you have any questions or want more feedback on your submission, feel free to post in the discussion forums, and we, as well as your peers, will be there to help you.